Hi, I'm Cailin. I'm so excited to be joining you all at JuliaCon 2022 and to hear about the amazing things that people have been doing with Julia. Today, we'll be talking about the BanyanONNXRunTime.jl package, a package for large-scale machine learning inference in Julia. But before I dive into ML inference and what ONNX is, let's first talk about what Banyan is. Banyan is a suite of packages spanning both the Julia and Python programming language, and as well as a complete platform for large-scale data processing in the cloud. Banyan Julia packages leverage existing Julia packages such as DataFrames.jl, and they ultimately enable users to work with familiar Julia APIs on data of larger scale. Note that all Banyan Julia packages are fully open source themselves, but are part of a cloud product developed by Banyan Computing. If you want an on-premises solution, I would recommend that you also look into Dagger, MPI, and Distributed. In this talk, we will talk about how Banyan can help you run machine learning inference at scale using the BanyanONNXRunTime.jl package. First of all, what is machine learning inference? Machine learning inference is running a trained machine learning model on data to get outputs. How to run a machine learning model usually depends on how the ML model was trained. There are many ways a machine learning model might have been trained, but often it was either trained in PyTorch or TensorFlow, or maybe Flux.jl. This is where ONNX comes in and is really useful. ONNX is a standard file format for machine learning models. No matter whether your model was produced and trained and produced by TensorFlow or PyTorch or Flux.jl, you can export it as an ONNX file. But how do you actually run an ONNX file? If you are a Julia user, running an ONNX file is easy with the ONNXRunTime.jl package. This lets you load an ONNX file and then run the loaded model on a Julia array. The only problem with ONNXRunTime.jl is that it may take too long to run with sufficiently large arrays. Simply running it on multiple threads may not suffice because only part of ONNX runtime is empirically tested for thread safety. BanyanONNXRunTime provides a distributed version of the ONNXRunTime.jl package. The API is almost exactly the same, and you can pass in a Banyan array to a BanyanONNXRunTime session. In this example, we read in an ONNX model stored on GitHub in an HTTP path and use it to operate on an array of images. Banyan generates code that uses ONNXRunTime.jl and parallelizes the machine learning inference across workers running together in a cloud computing session on a cluster. The result is massively parallel ML inference on Julia arrays using a consistent, familiar Julia API. So what's next for Banyan Julia and machine learning? We plan to develop BanyanFlux.jl, which will parallelize training of machine learning models. Prior work in Harvard has shown the effectiveness of MPI for parallel ML training, and since Banyan integrates closely with MPI via MPI.jl, we expect to achieve very good performance for distributed ML training. For more details about BanyanONNXRunTime and the other Banyan Julia packages, please check out our documentation on our website at BanyanComputing.com. Finally, if you have any questions or comments or feature requests, please do not hesitate to reach out to us via email or over Slack or open a GitHub issue. Thank you so much for listening.